Joe.
Yes.
What do we know? What's something we know about inverse functions?
Okay, so you can determine if there is an inverse function by the horizontal line test.
The horizontal line test, and how does the horizontal line test work?
Well, if you sketch a horizontal line. Okay, let me finish, please. Thank you. You sketch a horizontal line, and if it crosses the function twice, intersects the function twice, then it isn't. There's no inverse.
Okay, so to pass the horizontal line test, then our function needs to only pass. If we draw a horizontal line, it can only pass through the function one time. No, if you remember that, that's fine.
Okay.
Okay, so we're going to look at the inverse functions for 3 of our trig functions. And we won't worry about others. Next year in calculus, we don't really worry about values so much. There are some things we do with the other inverse trig functions. But let's look at y equals the sine of x. Does this function have an inverse trig function?
No.
Why not, Ben?
Horizontal line test.
Horizontal line test. If I were to draw a horizontal line, it would pass through the sine curve an infinite number of times, because theoretically that keeps going on and on and on and on. So it fails a horizontal line test. But what if I make a restriction from here to here? And just look at this part. Would that pass the horizontal line test?
Yes.
Yes. So we find, and we saw this too when we were dealing with quadratic functions. If we looked at either x greater than 0 or less than 0, we could get an inverse function. But here, what we're going to do is restrict our domain for the sine to between negative pi over 2 and pi over 2. And that should allow me to have an inverse function. Now, what is the range between negative pi over 2 and pi over 2? 1 is the range?
I mean, no, 2.
Wait, what?
Ben?
Negative 1, 2.
Wait, negative.
Wait, Ben. You look like you have a thought in your head that you might know what the range is.
Actually, it's just TV static, though.
William?
Negative 1 to 1.
Negative 1 to 1 is the range. Remember, range is simply the minimum y value to the maximum y value. And that's what it is for y equals sine x, y equals cosine x. Okay, that's always what we knew it was going to be. Okay, so we're looking at inverse function. What happens to the domain and range of the function that's the inverse of this function, Molly? It switches places. So here, this is y equals the sine of x. The inverse function can either be written as y equals the sine with a little negative 1x. If you've seen that on your calculator above the sine, you have that sine negative 1. That doesn't mean reciprocal function. That's your inverse function. Or it's also sometimes written as the arc sine. Either way, they mean the same thing. The inverse sine of x has a little negative 1. To get to it on your calculator, you do second sine. Or y equals arc sine of x, same way on your calculator, second sine. But you'll see it both ways. In calculus, my book usually uses the arc sine more than it uses the inverse, but they are interchangeable. And so if we're looking at the inverse, I'm going to draw a line here so we know that there's a difference. The domain of the inverse then is going to be what? Negative 1 to 1. And the range of the inverse is negative pi over 2 to pi over 2. Okay. When we're dealing with the inverse sign or the arc sign, we're only looking for values that are between negative pi over 2 and pi over 2. So let's look at an example. I'm going to move this out of the way, and I'll bring it back in a minute. I want to find the arc sine of -1/2. Now, we're only looking between -pi/2 and pi/2. So, what this is really saying, and if it helps you to rewrite the problem, what this is really saying to us is the sine of theta equals -1/2. What angle between -pi/2 and pi/2 has an angle or has a value of -1/2? Now your answer's not going to be, it's going to be between -pi/2 and pi/2. Think about your, it's between here and here. So if it's in quadrant 1, it's a positive angle. If it's in quadrant 4, it's a negative angle. Okay, so what angle has, first of all, what angle has a sine of 1/2? Pi/6, but this is a -1/2, which tells us it is right here in this quadrant. So the theta is -pi/6.
Would you prefer radians, I guess, in this case?
It has to be radians
Okay.
if we're looking between -pi/2 and pi/2.
Wait, could it also be, does it have to be negative? Could it be like-
Yes, it has to be negative because our domain is -pi/2 to pi/2. We can't go outside that domain.
It would have been 11 pi/6.
I don't.
That also has a value of -1/2, but not for the inverse function. Because
okay.
this is an inverse, you can only have either a negative acute angle or a positive acute angle.
Okay.
All right, so let's think about this.
Thank you, that makes sense.
This is the same form, it's just a different format. Still means inverse sine. Arc sine, inverse sine, same. So this is asking me, except I wrote it down wrong, this is asking me for the angle whose sine is the square root of 3/2. So if it helps you, you can rewrite that. You don't have to, but sometimes, especially when we first start, it's a little more helpful if we think about rewriting it. So what angle has a sine of the square root of 3/2? Pi/3. So theta is pi/3. We use the inverse function when we are looking for the angle. Right. Before Christmas, we found that there were multiple angles that had a sine of square root of 3/2, but because this was given to us as an inverse function, it can only be between -pi/2 and pi/2. All right, let's do another.
Ms. Cole,
Mm-hmm.
will it always be between -pi/2 or pi/2, or is it stated in the question?
If you are dealing with an inverse function, it's always, for sine, it's always -pi/2 to pi/2. That's a good question. For the inverse sine, it's always -pi/2 to pi/2.
But that's just sine, it's different for cosine. Tangent.
All right, let's look at the arc sine of -1. In other words, what does this mean? If I'm saying the arc sine of -1, what am I trying to find? The angle whose sine is -1. Okay, what angle has a sine of -1 between -pi/2 and pi/2 inclusive?
Oh, it's wait, it's 0, right?
What did you say? -pi/2. We cannot use 3pi/2 because this is the arc
They
sine.
are inclusive?
They are
Okay,
inclusive.
thank you.
They are inclusive.
I don't just.
Okay.
Oh, yeah, just
They are inclusive. Okay. Uh-huh.
I don't understand because the only one is at the very bottom of the unit circle, right? 0, -1.
Yeah, but that only
So,
3pi/2.
That's 3pi/2. What?
It's
where do you-
-pi/2
Oh, it's the same.
because we're dealing with the inverse sine. You cannot have an obtuse angle. It has to be acute, either positive acute or negative acute.
So you just went backwards.
Oh, we went
That
backwards.
is hard to picture.
That's only when you're dealing with inverse, Max. Inverse sign. You can't use 3 pi over 2. It has to be negative pi over 2.
So like in inverse, we're going clockwise, but like in the normal signs, we're going, but in a normal unit circle, we're going anti.
Yes, counterclockwise, yes. Okay, what about one last one with the sign? Okay, what about here?
Wait, is that?
Oh, there should be a 1. All right, so I really want to know what angle has a sine of the square root of 3. What did we say when we made our restriction on the sine function, what did we say the range was? -1 to 1. Does this fall within that range? Square root of 3, so greater than 1? So it does not exist. There is no angle whose sine is equal to the square root of 3, because this is greater than 1. Okay. There is no angle whose sine is the square root of 3, because square root of 3 is larger than 1. Will y equals the cosine x pass the horizontal line test? No. Would it make sense to make the same restriction here that I made on the sine?
No.
That still wouldn't pass the horizontal line test. Where might be an easy place to, Justin said 0 to pi. Does that look reasonable?
Yeah.
Would that part of the cosine curve pass the horizontal line test? All right, so for the domain on the cosine, I'm going to restrict it between 0 and pi. From here to here, because now this part of the curve would pass the horizontal line test. All right, so we restricted it 0 to pi. What's the range? -1 to 1, still the same. So if we think about the inverse function, y equals the inverse of the cosine. Uh-huh.
How do you got a range? I know it's -1 and 1.
How do we know it's -1 to 1, Kathleen?
Well, I don't know, so it looks like it's 2 and then -2.
Well, that's 1. That's -1.
But the amplitude is 1.
Oh, okay, I thought it was 2.
Okay. Oh, sorry. No, I was marking those as each a half.
Will we be making our own restrictions, or?
For inverse sine, the restriction on the sine is always -pi over 2 to pi over 2. For inverse cosine, it's always 0 to pi. All right?
But
So,
what if there's, will they give us, maybe a cosine, problem, that they have a phase shift? Not with inverse functions. Okay.
Not with inverse functions. All right, so if we're looking at our inverse, what's the domain? -1 to 1. And the range is 0 to pi. That means your answer, if your problem is an inverse function, that means your answer has to be between 0 and pi. Okay, the value of the inverse cosine is between -1 and 1, but your answer, the angle that you're looking for, is going to only be between 0 and pi. Right? And right now, I'm not going to take the time for us to look at the inverse function, but you could go to your calculator. We already have the window set. You could put in y equals cosine x and y equals the inverse of the cosine of x and see what those two look like. I think it ends up being something like this. I'm not exact. I mean, that's just quick. We could take the time and reverse the points, but I want to get a little bit further than what that would take to do today. But you can look at that on your calculator. The x and the y's change values. The graph of the tangent of x, this is -pi over 2, pi over 2, 3 pi over 2. And then if we add 4 pi over 2 to that, we'd get 7 pi over 2. Okay, here's where our asymptotes are. And the graph of the tangent we know looks like this. Hopefully we know that. Off a little bit, but will that pass the horizontal line test?
Oh, yes.
Y equals tangent of x, that passes the horizontal line test? No. What might be a reasonable restriction do you think might have been made so that we could pass the horizontal line
It'd be
test?
just one period, yeah.
Just one period. So
Pi halves to pi halves.
negative pi over 2 to pi over 2. Do we include this time? No. So it's the domain for the restriction we're going to make is between negative pi over 2 and pi over 2. And we do not include the pi over 2 or the negative pi over 2 because that's where your asymptotes occur. It's always negative pi over 2 to pi over 2. It's never going to be pi over 2 to 3 pi over 2. So sine is inclusive, negative pi over 2 to pi over 2 restriction. Tangent is exclusive, pi over 2 to negative pi over 2 to pi over 2. What's the range? Negative infinity to positive infinity. Max, you have a question?
So you mean the domain for a tangent is always going to be negative pi over 2 and positive pi over 2?
Yes, for the inverse tangent. Yes, yes. There are restriction so that we can use the inverse function without including those in values. So if we look at the inverse tangent or the arctan, they both mean the same thing. What's the domain of the inverse? Negative infinity to positive infinity. And the range? Negative pi over 2 to pi over 2. So let's, yes.
What you said about inclusive.
Okay, so let's see if we can find the arc cosine of square root of 2 over 2. Okay, Savannah, you came in late, so basically what that means is, I know the value of the cosine of the angle. I don't know what the angle is. I'm trying to find the angle. So if you want, you can rewrite that as the cosine of theta equals the square root of 2 over 2. And what did we say it has to lie between for the cosine?
0 pi.
It's from 0 to pi. So the angle has to be in either the first quadrant or the second quadrant. There will be no negative angles for the inverse cosine. So what angle has a cosine of the square root of 2 over 2? Pi over 4. If you know your unit circle values, you'll do pretty good. Okay, the angle whose cosine is negative 1. What angle has a cosine of negative 1? If you want to rewrite it, you don't have to, but you're finding an angle. So theta equals not just pi. It can't be a negative number for cosine, for inverse cosine.
Wait a second. I thought the values were between negative pi.
That's inverse tan and inverse cosine.
What's
This,
that?
I mean inverse sine. This is cosine.
Cosine, yeah. It's between, 0 and pi, okay.
Okay, what about the arc cosine of square root of 3 over 2? What's theta going to be? That means I want the angle whose cosine is the square root of 3 over 2. So theta is
Pi over 6.
pi over 6. The angle whose cosine is a negative 5/10. What's negative 5/10?
1/2.
Negative 1/2. What angle has a cosine of negative 1/2?
Oh, pi over 2.
negative.
but it's not negative. So what quadrant does it have to be in then, Justin?
If the cosine is negative, it has to be in 2.
Quadrant 2. What's the angle in quadrant 2 whose reference angle is pi over 3?
Pi over 3.
2 pi over 3.
I got it.
Yes, ma'am.
Can you explain what you just told Justin? Like, why is it not pi over 3?
Because this is a negative value right here. Okay, in pi over 3, the is quadrant 1. Okay, so we know we're looking between 0 and pi, so that kicks it into the second quadrant. The cosine's negative in quadrant 2. All right, let's look at a couple of tangent values. The arctan.
Miss Colville?
Uh-huh.
So for sine, it's like the quadrant 1 and the quadrant 4, and for cosine, it's quadrant 1 and quadrant 2.
Correct. But the quadrant 4 is going to be a negative angle, not a positive angle. Angle whose tangent's 0. Where are we? Where are we looking in the tangent between what and what?
Negative 2 pi, negative pi over 2 and pi over 2.
Negative pi over 2 to pi over 2. So the angle whose tangent is 0 is, I heard it a minute ago, 0.
Oh, yes. Yes. Okay.
And if you know what the graph looks like, you know the tangent crosses the x-axis at 0.
Oh.
All right, the angle whose tangent, or the arctan, or inverse tangent is -1. So what's theta?
Theta is something. It's like something of pi over 4.
Okay, what
Negative
a
pi
pi?
over 4.
Negative pi over 4. All right. The inverse tan of square root of 3 over 3. In other words, the angle whose tangent, not square root of 3 over 3, we don't know that, over 2. I have it written down wrong.
Wait, no,
Wait, tangent is.
No, it is square root of 3 over 3. That's right. Thank you, thank you, thank you.
Right.
Theta equals pi over 6. All right.
Wait, what's the negative?
Okay, we want to be sure that you can get that in there right. So let's look at the angle whose sine is 0.2447. The inverse sine of 0.2447.
0.2472.
Okay, you should get approximately 0.2472. You must be in radian measure. If you're not getting that, it could be because you're not in radian measure. Did anybody have a problem with that one? All right. What about the arc cosine of 2? Why do you think you got an error?
Because it's more than pi over 2.
This is larger than 1. So,
But I thought cosine
it does
was
not
between 0 and
exist.
pi.
Okay, what is the domain of the inverse function for the, it's going to be the same as here. It's -1 to 1. That means that when it's in this form, this number has to be between -1 and 1.
Wait, what?
Wait, I thought it was between 0 and
Yeah.
That's what your answer is going to be, is between 0 and
Oh, wait.
pi.
Oh, got it.
Because this is the inverse function.
Oh, so it's like, flipped around. Okay.
All right, that's the inverse function.
Cool.
On your homework, you're going to be asked to use a figure that looks something like this. You're going to be asked to use an inverse trig function to write theta as a function of x. Okay, we want to write theta as a function of x. Using inverse trig functions. All right, so to do that, in other words, you want theta is going to be equal to something. If we're using inverse trig functions, what trig function would we have here? We have this side and this side. What is that? Okay, so theta is equal to the arctan, or you could use the inverse tan of what? What is the tangent of theta? X over 4. That's all it's asking you to do. You've got a right triangle. Some of your sides will be labeled, and you'll be asked to write theta as an inverse trig function, using inverse trig functions. All right, if we had another one, for instance, let's say this again works with right triangles. This is theta, and this is 5, and this is x plus 2. Theta equals what? William?
Inverse sine of x plus 2 over 5.
Inverse sine or arc sine, either one is correct. The inverse sine of x plus 2 over 5. That's all it's asking you to do on the last few problems I'm going to ask you to work on. All right? So your assignment, and I will, when we get off here, remind me to change it in RenWeb. I want you to do page 347 and 6 to 18. We'll do evens 24 to 48 every third. Okay?
Only the evens that are every third.
No, 6 to 18 evens.
Oh, sorry.
24 to 48 every third. I think we'll stop there. On Friday, we'll talk a little, we'll still be working with inverse trig functions and talk about the definition of inverse functions. But I think this is good for today to give you some practice.
Oh my gosh.
Yes.
Yeah, not average.